Okay, everyone, I hope you had a brief lunch. Thank you for joining us. This is session 2AD, and we have Patrick Becker speaking to us on the recovery challenges in DB2 for zOS. So thank you very much, Patrick. Over to you.
Okay, thank you very much, Marcus. Okay, hello everyone. Good afternoon. So thanks for joining in these, let's say, special times. I hope all of you are safe and doing all right on wherever you are. So the idea of this session was to take you through the different recovery challenges and scenarios that you may encounter in your life as a person working with DB2 for zOS, and also try to point out ways out of any complex recover situations. I would just want to share ideas and thoughts how certain scenarios can be approached in the best possible way. So this is the list of things, little agenda that I put together where I would like to take you through. Before we go into the recovery scenarios themselves, I would like to have some basic conversations to talk about general terms and backup policies, backup strategies, recover strategies. And then I would like to cover 4 different recovery scenarios. I would like to start talking about the point-in-time recovery, which is probably a scenario you may encounter the most if you have to recover data, which is probably also going to be the easiest of those 4. Second topic we are going to investigate is the so-called transaction recovery, where you find certain applications or transactions corrupting your data. Then we will talk a little bit about a DBA nightmare, dropped object recovery. Certainly nothing you would want to hear about when the phone rings at 3 o'clock in the morning. And last but not least, I would like to talk about a topic that's called redirected recovery. It also has a good purpose, and there was just a very recent enhancement shipped by IBM for DB2 for zOS that can also help you with redirected recovery. And we are going to have a look at some of the details of that. Okay, so let's start with the basics. So when it comes to recovery in DB2 for zOS, the most challenging thing is that you probably don't do it every day, which means as long as you don't have your libraries, your procedures, your solutions set up, it may need sync time to actually get your head around of what was happening and how you can address that specific error situation. So it's like every other task. If you do it every single day, you're very, very confident in what you're doing. But if you're not recovering your data every single day, which I just pretend you're not doing, complications will easily arise. As always, recovery always comes at an inconvenient time. It normally, just by Murphy's Law, tends to happen at Saturday or Friday morning, 3 a.m., and not on 10 a.m. on Tuesday morning. It's just the way it is. Thanks to Murphy for that. So whenever you get a call as the person being responsible for recovering certain objects in DB2 for zOS, the first thing you need to understand is what the heck went wrong. What has happened? You need to understand the error that occurred in order to figure out the best way forward. Was it a dropped object? Did somebody accidentally drop an object? Or was there an application corrupting your data? Or did your organization suffer from a hardware failure, potentially a DASD storage device that just got some hiccups? Was there a human error? And you can easily imagine that all of these scenarios would have different resolutions. You can't always apply the same methodology, the same recover logic to recover out of these failures. All come with their complexities, and that's what we are going to discuss within the next 55 minutes. The first thing you need to do once you understand what happened is you need to do some additional research to determine what needs recovering. And it's typically not only that particular table where you have observed a failure, but if you think of application built-in referential integrity or DB2 supported referential integrity, data integrity or referential integrity, there's typically more than one table that is involved. We have a customer They have referential integrity definitions on a single table to 450 other tables. So that's massive. And I would say the DBAs really love that application if something goes wrong, as you can easily imagine. Db2 for zOS outside of the box provides really good utilities that are available with Db2 for zOS to help you with recovering data. Of course, there's a recover utility. You have the check data utility to check your referential constraints. You have DSN1 copy to move VSAM datasets from one place to another. You can print a Db2 for zOS log, but also all of these actually have their limitations and you need to know how to use them. So it's very hard and seldomly practiced. I think that's the biggest challenge, actually. Before we go into more details, I would just like to make ourselves familiarize with probably some of the well-known terms. Probably not all of them have heard you, so I'm trying to briefly go over them. These are recovery point objective and recovery time objective. And normally your organization, your IT department has service level agreements for both. And actually both need to be considered. So what's a recovery point objective? Essentially, you can ask yourself the question, how much data is my company willing to lose before we encounter any significant harm? How much data loss can actually be accepted? So this is your recovery point objective. For example, if your database was corrupted at 2 o'clock and you have a safe point, or if your business tolerates to have a recovery point objective that's just X minus 2 hours, and you have an image copy from 2 hours ago, you can easily restore to that image copy. Okay, you have 2 hours of data loss if the event occurred at 2 o'clock. And if that's within your service level agreements, then it's totally fine. But in most companies, losing data for the last 2 hours is just not an option, right? Think of banking, think of retailers. Losing 2 hours worth of data is just not going to option. It can cause far more issues than anything else. For the IT department, the challenging and the interesting question is, what is the right recovery time objective? Or in other words, how long is your enterprise, read your management, willing to wait until all applications have been successfully restored? In my previous life as an application developer, just to give you an example, there was a situation at a bank in Germany where they encountered a massive outage because some technician unfortunately pulled the wrong plug from a DASD device. So they just disconnected the DASD device from the mainframe, from the central CAC, which was a nightmare. And that outage costed them about 200,000 euros per hour. So that's pretty significant. And you may also want to differentiate between applications for the right recovery time objective. So if you're a bank, if your core banking system isn't available, that's going to cost you far more than if a data warehouse or BI environment that's just used for analysis is not available. And we'll talk more about these different applications later on. If we look into a bit closer to recovery time objective, if you look on the lower left-hand side, somebody normally detects an error. Then that's the point in time about a couple seconds later that your phone rings and you start the investigation. So you start to determine the scope of the recovery exercise, and then let's call it the RTO clock starts ticking. You start to determine the best strategy for your recovery. Is it to recover forward? Is it to recover back out? Then you put together all the recovery jobs that you may need to bring the data back in shape. And typically, that's when you get more costs from your management. It's just the way it is. In order to reduce the recovery time needed, you may think about running these jobs in parallel. Now, do you have enough resources? Let's think of SortWork data sets, for example. Can all this be run in parallel? So that's what you also spend a couple of thoughts on. Finally, you will end up submitting the jobs. Some of them are probably going to fail. And you start all over again. And at one point in time, management just makes an appearance, just the way it is. And from that point in time, when you determine the best strategy for recovery, until the successful recovery. This is what we call the RTO. You typically loop through these steps or iterate through these steps until the recovery is successful. And when you look at this chart or this little graphic here, the sync time, the time when you put all this together, plus the execution time, that's the time of the unplanned outage where you're actually spending pound sterling or dollar. That's what costs your company a lot of dollars. So what some customers do, not all of them, I found that they do recovery simulations, which I personally believe is a good thing. So the auditors typically tell them, okay, so now we are in a situation, please assume person A, B, C, D, and E are not available. We have to recover databases 1, 2, 3, 4, 5. Go ahead. And by running that type of recovery simulation, they make sure that the people stay trained and also have good experience and know what to do in case it's a real disaster that's happening. So which objects are affected? Referential integrity is one thing, but then there's the application built in RI. So we have had situations at customers where the DBAs were just recovering the objects that they thought would needed to be recovered, but then the application people showed up and told them, well, you had no idea that we have these 8 other tables that are integral part of the application, so these need to be recovered as well. So in order to understand which objects really need to be recovered, I would strongly recommend to always have a chat with the application people. Now, then the next question is, okay, what's the best path to recovery? What's the best way forward? We briefly spoke about point-in-time recovery of an individual application or an individual object, or do you have to back out certain transactions where you just moved a module into production that corrupted your data, but only subsets of data? That's probably the most challenging recovery type that you have. Do you just have to recover a dropped object, or do you have to recover objects to another environment to do some forensic analysis? That's what we refer to as redirected recovery. So each of these methods we will go through, and each of them has pros and cons. In terms of the backup strategy, so the key for a simplified recovery is really to have a good backup policy. You normally, or you would need to understand, when was the last image copy taken, or do we constantly take system level backups? What's the right frequency to run these copies? What plays into this is how fast is an object actually changing? Do you have an OLTP environment where a table receives hundreds, thousands of updates per hour? Then you need to take this into account, because when you restore from an image copy and you have to apply millions and millions of log records that were sitting on 24 hours of archive or active logs, it may just take far longer, which means you could think of increasing the image copy frequency here. Another item that's almost a lost stepchild is indexes. We always think, nobody needs to copy indexes. You can always rebuild them. That's true. We have seen customers where the rebuild of indexes just accounts for 3/4 of the entire elapsed time, because they had these massive non-partitioned indexes on this multi-terabyte table, and that rebuild just took forever. So if you have such scenarios, especially large NPIs, you may want to consider copying your indexes to reduce your recovery time objective. The other thing where I've also been burned in the past, if you so will, is the amount of time. How many DB2 logs do you want to keep on DASD? In my previous life as an application developer, DASD space was terribly expensive, and the system programmers, the DBAs, they told us, no, our policy to move the archive logs to tape and to keep only 4 hours of active logs on DASD is fully sufficient. So, well, we unfortunately we proved them wrong. So we just ran an experiment with that setup. We created the same tables like for our core banking application. We just ran 2 updates every 10-15 minutes for the course of a day, and we just recovered the data at the end of the day. it was back in DB2 version 5, if I recall correctly. There was no thing as a virtual tape by then. So at the end of the day, that recover process, just to read through all the volumes of DB2 log data, back at that time, that just took multiple hours. And I think beginning the week after, they decided to have 48 hours of DB2 logs on DASD. Sometimes it's just a hard way to actually learn that lesson. What else? Image copy. The application developers and application owners can typically tell you what's the best way to back up the data. They can tell you when tables are manipulated and advise on recoverability needs and affected objects. So some customers decide to just let all the backups being taken automatically. But if you really want to apply some logic here, having a chat with the application developers will probably help you significantly to come up with a better backup strategy. So for example, if you have this slowly changing table that's always changed every first Monday in a month, that may just not need the same backup strategy or backup policy as this table that's heavily hit by OLTP transactions. We briefly touched on index copies. Another thing, especially when it comes to drop objects, is to have a copy of the DDL. So you may want to have a centralized storage or repository, if you so will, for all your dataset definition language entries. And if you have absolutely no idea when you should run maintenance for your objects, such as image copies, you can always fall back and use ds&ecocs, which is a DB2 for zOS supplied stored procedure. In combination with real-time statistics, ds&ecocs can make recommendations on when to take image copies of your table spaces. It also makes recommendations for other utilities such as run, stats, and reorgs, but it can also be used to make your get recommendations for running the copy utility. In terms of backup media and technology, I would like to briefly touch on fast replication. Different vendors provide different solutions. The IBM solution is IBM Flash Copy. Then EMC calls it Time Finder. I think Hitachi calls it Shadow Image, if I'm not mistaken. All these are excellent technologies, but you need to watch out when you apply them. So for example, creating Flash Copy consistent image copies in DB2 for zOS sounds fast, but it really isn't, because a Flash Copy consistent image copy will make the image copy consistent using the Flash Copy technology, but it would require access to the DB2 log to back out any uncommitted units of recovery. So creating Flash Copy consistent image copies is not something you would do for performance, just to point this out. And then of course we have this remote site mirroring. If you run a secondary site to use, which can use GDPS PPRC, which is a synchronous mirroring on your storage device level, or GDPS XRC, which would asynchronously replicate the changes to your DB2 data on the disk level to a second environment. Now, that's for the basics for some of the terms and technologies, but now let's go into the recovery scenarios themselves. Let's start with point-in-time recovery. So what is a good recovery point? As I said before, the person knowing the application would be a very good source to help you with that. Once you understand what needs, which objects need to be recovered, always watch out for those referential integrity constraints that you have. If you're just recovering base table spaces for XML data, for LOB data, remember there's always an auxiliary table. Include all of these, otherwise you will just be disappointed after the initial recovery exercise has completed. Then you need to check what recovery assets are actually available. What do you have available to use for this recovery? Do you only have that image copy from 2 weeks ago? Hopefully not. Do you have a system level backup that you can use? Is that based on tape, or is something available on DASD? And what is the best recovery method that you can choose? If the image copy was taken 2 days ago, let's say, it was a table that has been updated for the last 48 hours, and you just need to go back half an hour in time. It might be faster to just use recover with backout to just back out the changes from the last 30 minutes from the log. Can you do a recover to copy? Or is it more efficient to recover to an image copy and roll a log forward? So all these considerations need to be, or all these options need to be taken into account, and hopefully not when you are under in a high stress situations. Well, but chances are. I would recommend to assess this individually and not recover all the objects with the same method, just based on the fact that the objects all have different characteristics. And once you have created the GCL, you certainly need to monitor and manage the execution of the jobs. If it's only 1 or 2 recover jobs, that's one thing. But if the recover gets more massive, you may want to pull in your colleagues, serve an extra cup of coffee, and make sure you can all monitor and manage the execution of the jobs as a team. So let me share you a real life customer case here. That customer released or has a release process to roll out new software to all their clients twice a year. They have a 3 to 4 digit number of jobs that migrate their applications from one state to another. And there are many Db2 jobs in there that just modify existing tables. And there was this one job, the one that you see here, that was executed. And at one point in time, people noticed that many of these migration jobs, of these hundreds or thousands of migration jobs that were planned to be executed, started to fail. It took them a while to figure out what was going on, because finally somebody entered this member here in browse mode. And that's what he saw. You may spot the semicolon here. And what nobody realized is that this job didn't only take 1.5 seconds just to lead a couple of contracts that have been opened on the 1st of January in 2017. So these were just supposed to be deleted, but somebody just made a mistake and added a semicolon here. So what happened is they deleted all the contracts from that table, and that table had cascading deletes defined on it, which meant that the entire contract database was erased. So, and that removed all the contracts for the companies, for the banks they provided the IT services for. So this was a nightmare. So what they had to do was a point-in-time recovery. So first thing they needed to do was to identify the point in time that they needed to restore the objects to. So in this case, this was comparatively easy. They just had to go to the job and see when the job started, and then they could easily identify the time to which they need to recover this database to. Then they had to identify all the objects that had referential constraints defined based on that contract table that was just erased. And you can easily tell that the complexity can grow exponentially the more objects are involved here. Then they needed to decide, can I recover the entire table space, or do I have to go with individual table recovery, because they still had segmented tables or multi-table table spaces back then. They had to rebuild to build a recover GCL, including the rebuild jobs for all the indexes, and decide between the available recovery options to get the best elapsed time here. And then for some of the jobs, they had to go back because they figured out that the image copies have actually already been removed from tape. They were still recorded in sys IBM syscopy, but there was another challenge that they faced because the retention period for the image copies already had expired. So that was a little bit of a nightmare. So when they submitted the recovery jobs at the end, they had to run the check data tool in order to make sure all the referential constraints are in place. The jobs that have ended needed to be restarted after troubleshooting. And then, of course, image copies should be taken after a successful recovery. That's always a good practice to do so. So then you think you're done. You go to the coffee machine, you breathe again, and then the phone rings again. Why the hell is that? So if you then find yourself in the situation that you overlooked that multiple tables had data capture changes yes defined, which is typically the case if data is replicated to other environments, you have to recover these environments as well. So that's also another thing that you may want to catch early in the cycle just to make sure you do not forget all these systems. If the depending system is an IBM DB2 Analytics Accelerator, for example, that might be easy, that can be reloaded. But if you're using data capture changes to replicate the changes to totally different environments with, let's say, less integration, that might be more of a challenge. That's certainly something that you would want to watch out for. Let's have a look at the transaction recovery, which is, I believe, the most complex one. So what's the purpose of a transaction recovery? Think of a transaction recovery like somebody moved a load module into production that was about to corrupt certain rows in your table. Not all of some of the updates were good, others were not. So this is what we refer to as raw transactions here. It's just corrupting your data over time, and typically these type of errors are detected not immediately, but maybe a day or 2 or 3 later. So just going back in time 3 days with your database is not an option. There are multiple reasons why this can come up, and this is a real life customer scenario. An application corrupted the data during the batch window, and then it took 2 days for one auditor to actually spot, using the application integrated journaling, that there's some type of data corruption. Then the application developers started to investigate, and that's typically the point in time when you go to the coffee machine and try to figure out what to do. Because how do you back out the changes from that core banking system that only affects or that has been affected by this data corruption? Some of the updates were good, some of the updates were not good. So you just need to back out these updates that have corrupted the data. So that's a pretty challenging situation. In general, this is not easy to do. Again, there are many different ways to achieve this goal. You may get very familiar with the Db2 log during this exercise. So let's have a closer look and walk you through the steps that are actually necessary. So one approach is to restore the data back to another table, to recover it essentially to a different DB2 subsystem. But before you actually start the entire exercise, you want to make sure that you have corrected the application that has caused all this trouble. So the idea here is to recover the data to somewhere else and use that other DB2 for zOS subsystem or table in the same DB2 subsystem to analyze and correct the data. Here's a little bit of a fun fact. Originally, this chart showed tables in DB2A, tables in DB2B. We gave that chart a long time ago to an external agency who was supposed to allow me to say the word pimp, to pretty the chart up a little bit. And that's what I got. Remember, DB2A and some tables, and DB2B had some tables. So that's what I got. It took me a while to realize what they have done. Then, well, just a fun fact in the middle. So forget about that. Let's go back to this picture here. So then you have to reverse the transactions in DB2B and manually correct the data and then move it back via SQL, most likely, to your production subsystem. That task is a pretty or highly intensive manual task, and let's have a look at the detailed steps. If you find an image copy as close as possible to the module corrupting your application, or with a release date that's as close as possible to the time when the application was moved into production, ideally it was just taken before, you can unload or recover from the image copy to another table. Typically, you create a table structure either in the same DB2 subsystem or in a different subsystem. Normally, this is done, I would say, in a test subsystem because that's where you can easily manipulate the table with SQL statements, but not in production. Then you load the file that you have extracted from that old image copy into that new table in your test DB2 subsystem, and you grab an application programmer by the ear, you lock the door, you get tons of coffee in there, and you work out with the application programmer on which data you need to transfer back to DB2A in this case. So this is a highly manual process. You could, depending on what went wrong, just go with insert from select. So if you have, for example, if there was a wrong insert in DB2A, you may want to delete that data again. If there was a bad update, you must just create the right update statement to set the values back to the original statement. And you must have a way to kind of make these changes intelligently, because it would probably be a valid assumption that not only 10 rows have changed within 2 days, but many, many more rows would have changed. And the complexity can go through the roof depending on the number of changes that have occurred. And if subsequent transactions have updated the same rows, it gets even worse. Let's put it this way. So utilities that can be used to get yourself out of that situation certainly is the top one is probably dsnlogp. With a recent image copy, dsnlogp may be used to reconstruct the row image because dsnlogp only prints the log, but it doesn't necessarily log the entire row. So only in combination with the previous image copy, you would be able to construct a full row image. Then you have dsn1 print available. You can print formatted rows from DB2 pages, but if your DB2 table space is compressed, tough luck, then you only get compressed rows with DSN1 print. You can easily tell that this is going to become a complex exercise here. At the end of the day, it can be done without affecting availability, but you may only be able to return to a point in time of the image copy without destroying the other changes with this manual effort. The downside is it's really, really time consuming, and it must be done for all the objects that have suffered from this data corruption here. In order to determine what you need to undo, you have to submit multiple dsnlogp and dsn1 print jobs, and you have to analyze it, a highly manual effort. So if you talk to your vendor of choice, and all of you have your vendor of choice, talk to your vendor of choice, and it's very likely that they will have a tool available that could help you. And with any tooling that's out there from any vendor, you would most likely be able to scan the log for the time frame when you believe all these transactions have corrupted the data. You may be able to apply filters to help narrow down the search for the bad transaction, and all the transactions that have occurred there may be presented to you. And you can just normally, in all the tools from all the vendors, select the corresponding transaction so that you can just have undo SQL generated. So that would be my suggestion. Do not go for this individual effort, but really talk to your vendor of choice if they have anything available, and the answer is very likely going to be yes. So this is one of the most complex recoveries, and I would say this is the best way forward, because depending on the number of changes, it can be a nightmare, and it's probably more than a day that it will take to get back to a decent state. Let's continue with dropped object recovery. Normally, I ask in a presentation who has dropped the wrong object at one point in life. I'm the first to raise my hand, and then you see people looking around, and slowly the other hands are going up as well. I expect it to be kind of similar here, but given that we are virtual, I'm not gonna do this. So this is always known and was always known as a DBA's nightmare. Of course, if it's in production, it's worse. Test objects, well, you only block development. It's also not nice, but not as critical as production. And mostly it's just a human error, phase defect. The DB2 at one point introduced a method to mitigate the risk, to reduce the risk. It came with restrict on drop that you could add to certain objects. But then look at any solution out there, any smart application developer will just perform an alter and remove the restrict on drop before issuing any drop statements. So that's really not working as expected. And the bad thing is, as soon as you have dropped an object, the recover utility is disabled, because when you drop an object, for example, you drop a table space, all the syscopy entries are removed. So using the recover utility when a table space has been dropped is not an option anymore. DB2 just trusts you and removes all the related entities and entries from the catalog table. So in order to figure out what is removed, just to show the object relationships here, when you drop a storage group, that's probably one of the worst things you can do. Then essentially everything disappears. If you drop the database, you have a cascading drop to the table space and all the other objects that have solid green lines here. Orphans are created for packages. For example, they are invalidated, and the syscopy entries are removed if you drop a table space. If you only drop a table, you just leave the orphans in syscopy here. So there is a big dependency on the different objects in the catalog, depending on which object you actually drop. And now let's have a look on how you can bring back these objects. So first, you need to locate the DDL for the dropped objects. Hopefully you have a repository. And you also need the DDL if there were any cascading drops defined on that object. Again, you need an analysis for referential integrity constraints and application-based referential integrity. Again, talk to your friend in the application development team. You need to locate the data control language. So you need to understand who had which permissions to access the object. And you also need to understand the cascaded data control language. So who has granted which permissions to which other users. And you need to identify the plans and packages that have been affected by that drop statement. So the next thing you need to understand is you need to understand and find out which were the object IDs. The data, the DB ID, OB ID, and PS ID for both the dropped objects and the newly created object. Then find an image copy that's not registered in syscopy anymore. And what you typically do is you take this sequential image, or you take this image copy, and you use DSN1 copy with an option OBIDX to translate between source IDs, DB ID, OB ID, and PS ID in the image copy to the target DB ID, OB ID, and PS ID of the environment or of the object that you just created in DB2. And move that data set over into the new object. Alternatively, if you have an image copy, you can also unload it and load it to a new table space. Once the data has been loaded or restored with DSN1 copy, you can run rebuild on the indexes as they are required. When we come to log apply, that's the hardest part because you can't do log apply for an object that has been dropped. So you may be pretty limited in terms of recoverability. You may only be able to get back to the latest image copy that has been available. In a couple of minutes, we'll talk about a new option or a new scenario with the recover utility, and recover log only may possibly be used in some selected scenarios. Again, if you have defined referential integrity, you may need to restore the referential set back to the same point in time as you restart the object that just has been dropped. Now, same story as for transaction recovery. Um, your vendor of choice is likely going to have a tooling available where you can just determine the time frame when an object was believed to be dropped. You can tell it to scan the log, identify the dropped object, specify the recovery point, select the dependent objects that you may want to recover, tell it to bind the affected packages, and may do all that for you and even create the objects that have been dropped as a result of the cascading definitions in the catalog. The last topic I would like to touch on is redirected recovery. What is redirected recovery? Redirected recovery is used in many customer sites to assess the recovery time objective, to determine when you can resume normal business operations. You may have heard the question multiple times, how long will it take to recover? And typically you say, well, we can test, but that would mean an recover in place because you normally do not have the same amount of logging volume in any test or development environment. So what contributes to a recovery time is, of course, the number of affected objects and to a significant amount of log apply, because all the log reads and log apply processes will be a significant contributor to the overall elapsed time, depending on the log volume that you have to apply. Some customers have rented a disaster recovery site for these tests, but now there is an easier method to respond to the question, how long will it take to recover, with an enhancement that has been shipped by Db2 for zOS just recently. So, but before we go here, for all of us being in Europe, there is we all fall under the GDPR rule. And even in the GDPR, General Data Protection Regulation in the European Union, there's an Article 32 which says you need the ability to restore the availability and access to personal data in a timely manner in the event of a physical or technical incident. So even GDPR requires you to be able to recover and restore your data assets in time. At one point, you may be asked the question that we had on this previous chart, how long will it take to recover? And GDPR also plays into that. This is just an additional piece of information that I think it's valuable to share. So normally with redirected or the idea of redirected recovery is to take a backup and restore it to a different location. The different location could either be in the same Db2 subsystem, of course, to a different object name, different table name, or you could restore it to another subsystem. The primary use cases are to respond to the question, how long does it actually gonna take you to recover? Are you gonna satisfy your service level agreements? And you can provide the estimates to your upper management. But it also turns out to be very useful for analyzing any production problems, because you can't just hit the brakes in production. But if you can take an image copy from production and restore it to a separate environment, you may be able to debug your issue without any reduced availability in your production. Other customers use redirected recovery to create test data in non-production environments. Of course, they need to additionally anonymize the data, but all that can be done with redirected recovery. So let's go on a little excursion here. The recovery time objective verification with the Db2 recover utility. The following PDF has been released with Db2 for zOS UI 72057. It requires Db2 12 function level 500 or higher. I hope many of you are at that level at this point. And the use cases are exactly the ones that we just have discussed. Assess the current recovery time objective. You can recover your production data to a separate target without impacting the original data and the original applications. You can find out if you have any issues with potential recoveries. It can help you in debugging problem solutions, and it can help you generate data with transactional consistency, which is also of interest for many people running the test departments. An important note for this PTF, it only supports redirected recovery at this point for table spaces, and redirected recovery for index spaces is not available yet. That's the important one here. So if you're going to use this feature, you would still have to use the rebuild index at this point in time. So what does it look like? The syntax is pretty easy. You just recover table space. You specify target database dot target table space. You can specify it with dsnum or without dsnum, and then from source database dot source. Oh, it should be table space, not ds. Should be ts. Apologies. Same down here. That's the syntax, and that's what's going to happen is it will recover that table space to a different table space using the same recovery assets as it would use when you would run a recover in place. There are a couple of notes that come with the recover utility. It does not create the target object for you, but you need to make sure that you have defined the target object in the right way. So the critical attributes are the type and the organization. So it needs to be a universal table space. The page size needs to be the same, the data set size, sec size for non-lob table spaces. The member cluster attribute needs to be the same. Of course, the CCS ID needs to be the same. And for if you are recovering or if you're performing a redirected recovery for a partition by gross table space, the max partitions must be either equal. And there's another typo. You can review a presentation like this as many times as you want. You always find another typo. Apologies for that. So it must be equal or larger to the source. The image copies and the log records that have been taken for the source table space will be applied to the target. And it can support either flash copy consistent image copies or traditional sequential image copies. When you do a display utility, you may observe a new phase that's called translate, where it will translate DB ID, OB ID, and PS ID. May take a couple seconds, depending on the indexes on the catalog. The good thing is all the source objects will remain available for your applications. There is no impact whatsoever on the source objects. The target object, as you would have expected, won't be available for read-write access until the recover utility completes. So it will be in UT status when you do a display database use. The recovery point, and that's also good news, can not only be a specific point in time, can also be to current. If there's any uncommitted work or any units of recovery are open at that specific point in time you want to recover to, they will be backed out at a target. So the target will always be consistent, right? So there are no open units of recovery, and the indexes need to be rebuilt. Some of the limitations I mentioned before, that you have to be in the universal table space land. So not supported are partition non-UTS table spaces, simple table spaces, segmented non-UTS table spaces. Hash organization table spaces are not supported. It does not support table spaces that have a clone relationship defined on it, and you can't use it on Db2 catalog and directory table spaces. The other one that we definitely need to point out is that the target objects must reside in the same Db2 for zOS subsystem or data sharing group. You cannot use recover with the syntax that we just have seen 2 slides ago to recover an object to a different Db2 for zOS subsystem. They're just not supported. Also, some other options are not supported. For example, you can't do a back out or error range recovery, for example. So when we look in more detail at the redirected recovery, so the steps to successful recovery are, first of all, as always, select the objects that need to participate in redirected recovery and select the environment where you would want to recover your objects to. And you are responsible to actually create these objects to be available for recovery. Now, of course, the easiest thing if you are in function level 500 is to use the redirected recovery option that we just have described. And that's definitely, I would say, the recommended most easiest way. So if you're not at function level 500, you may want to consider migrating to function level 500. Might be another good reason to push the migration forward, but I hope many of you are there already. Then you just select the recovery point, you use the recover utility and rebuild the indexes as it is required. Now, things are going to be a bit different if you are going to recover to a different DB2 for zOS subsystem. First of all, if it's a different LPAR, you need to get hold of the image copies and copy them over to the target environment. And normally there is no disk or storage DAST sharing between production and non-production environments. So you need to find a way to move these data sets over to your target environment. Again, you have to determine the combination of DB, OBID, and PSID for both the source object in production and the target objects in your target environment from the DB2 catalog. Then you could use DSN1 copy using, again, the OBID XLAT option to translate the 3 IDs that you just have determined, rebuild the indexes. Now, then if you really require to get the data up to a specific point in time, you may have to use, again, tooling from your vendor of choice to generate the required redo logs and move these SQL statements then over into your target environment and execute these statements there to make the target environment or to bring the target environment up to the point in time you requested to. So this was the overview that I have prepared to run you and take you through some of the challenging recovery scenarios. Maybe there were a few good ideas in here that you could benefit from. I think the biggest takeaway is to actually practice the recovery if you can. I know normally there's not enough time granted for these type of exercises, but I've seen too many situations where there had to be a big outage before management actually approved their DBAs to practice these recoveries. They're really essential exercises. It's money spent where you don't see an immediate benefit, but you see a benefit when it's really getting urgent. We have seen that there are many situations where it can be really difficult to recover from. There are always multiple options to get out of that. We have each of the solutions have different solutions. So the DB2 utilities help, but there might be many tools out there in the wide world that can help you to simplify the process. And you may possibly really appreciate any help. If you are boiling in hot water, your management is tapping your shoulder every 5 minutes. When can we please resume our applications? We're losing 200K per hour. That's probably one of the last things you would want to hear, because you're the data guards for your company, and your voice should be heard and help save your enterprise money in case a recovery event occurs, because we all want the business to continue as smooth as possible. So with that, I would like to conclude my session. And I would like to ask you to please submit your session feedback. So if you like the presentation, my name is Patrick Becker. If you did not like my presentation, Marcus David, right? That's your name.
Thank you very much.
Right. And with that, Marcus, I would like to hand it back to you.
Thank you very much, Patrick. That was excellent, really interesting and informative, very, very clear. Ladies and gentlemen, do we have any questions? Giving you a while to type. Nope, no questions.
Well, in that case,
so it just remains for me to thank you very much, Patrick, and please, everybody, don't forget your conference feedback, and don't forget to give a slight donation to what we to the conference charity. So thank you very much, everyone, and we shall see you soon.
Thank you very much, everyone, and enjoy your coffee. Enjoy the rest of the conference. Bye.